So what we're talking about is Chapter 2 review, and we discussed displacement already as a change in position. And so displacement is going to have units of meters or feet or miles. It's just a distance. So whenever you see something like a delta x or a delta y, you always know that's going to have some unit of length. So it's going to be meters or something like that. It's not going to be velocity. And whenever you see this is not velocity. That's just displacement, and that's just a length. It's a position change from one position to another. So we're talking about his position, and we said that when position changes, it takes some time to go from one point to another. When you walk across the street, it's going to take time for you to get across the street, which brings us to this concept of velocity. And we talked about something called average velocity, which is defined as whatever the change in position is over the change in time. If you're talking about vertical positions, it can also be a change in the vertical position over the change in time as well. Either of these can be expressions for velocity, and the units for that is going to be meters per second. What we want to do is take a look at a position versus time plot. So here's position. It's going to be measured in meters. Let's look over here and say this is at the unit of 5 meters. What's happening here in this graph? Well, if we look at this horizontal line, the position is staying at 5 over time. So what's the velocity? Velocity is 0. Velocity is 0, so average velocity is going to be 0 because the position isn't changing. It's standing still. In other words, it's standing at the position mark of 5 meters and it's not moving. So whenever you see a horizontal line in a position versus time plot, you know the velocity is 0. Look over here, this next one. The position is changing with time. As time moves from time 0 to some point, let's say this is point time 5 seconds, okay? And if I look to the left of that point right here, I'll read, let me say, let's just say this could be 10 meters, all right? So I have a position change. I'm going from time 0 to time 5, and I'm going up a straight line. If I have a straight line, then the slope is going to be equal to the average velocity. So in this case, the slope is going to be the rise. How far did it go up? That's the slope. That's the rise. How far did it go up or down? And this is here is what we call a run. How far over did it go? So the slope is going to be the rise over the run. And in this case, it's going to go up 10 units and over 5 units. So that's going to give us 2 meters per second plus. Because when you're going up this way, where you're slanting upward to the right like that, that's a positive slope. So the velocity is going to be positive. Let's say, for example, this is at position 20, and this here time is going to be, let's say, 5 seconds. In this case, we have a straight line. Again, it's position versus time, and this straight line is going to be negative, so this is a negative slope. Therefore, I know the velocity is negative, because the velocity is going to be the slope of the straight line. Anytime you have a straight line on a position versus time graph, you're going to get the slope of that line is going to give you your velocity. So in this case, the velocity is going to be the slope. It's going to be the rise over the run. Now in this case, you're dropping down 20 and you're going over 5. So you're going down 20 and you're going over 5 meters per second. In this case, then that would be minus 4 meters per second would be your average velocity for this kind of a plot. All right, so let's do this. Let's just clear this and pull up a new screen over here and show you something else. So let's do this. Let's say I have a plot look something like this. And let's say I'm going to go from here up, and I'm going to go over, and I'm going to go down, let's say like that. All right, so this is going to be time on this axis, and this is going to be position. Let's say it's going to be in meters. And I have some kind of a plot like that. So I could take a look. I could take a look at my time intervals here, and I can analyze the motion and say, what's happening over here? Well, position versus time. We know if we have straight lines, what we're going to see is velocity. All right? So in this case, what's the slope here? Well, the slope in this area here is going to be positive, and it's going to be, let's put some numbers on here. Let's say that this is 20, and let's say this is going to be 5. So the slope is going to be positive, and it's going to be 20 over 5. The rise going up 20 over 5, that's the slope of that. So this is going to be plus 4 meters per second right in here. So from here to here, you take the slope of this line, you'll have a velocity of plus 4 meters per second. Now what's going on over here? We're at 20 meters, and in this time interval, we're not changing our position at all. It's staying at 20. So therefore, the change in position is 0. The slope is horizontal, and the slope of any horizontal line is 0. So here the slope is equal to 0, so the velocity is 0. Now what's going on over here? Now we're going down, and in this interval you see the slope is negative. All right, the slope is negative there, so your average velocity is going to be negative. And let's see if we could calculate the slope. We're dropping down now 20. And suppose I say this is going to be 40 seconds where it finally hits the axis here. So it's going to be negative. It's the drop is going to be 20, and over it's going to and okay, let's say this is 5, and let's say this is 10, and so let's say from here to here then is what's the time interval from 10 to 40? It's 30. All right, so the time interval is 30 seconds. So from this point here to this point here, which is this triangle here that we're talking about, all right, we got an interval here of 30 seconds. So the rise, we're going to dropping down 20, and we're going over 30, and that's the slope. So the slope is negative 2/3 meters per second. So when you want to look at this then and analyze this kind of motion, you see that over here in this interval, all right, this interval number 1, we got something that's going in a positive velocity at a fairly good velocity. It's steep. So the steeper the slope, the more the velocity. And you see here it's 4. Here it's standing still, and in this phase it's still because the slope is 0. And here in this phase, the slope is negative. So in this phase here, we have a negative velocity, and we'd expect, since the slope is not as steep as it is in here, that the speed or the magnitude of the velocity is going to be less than the magnitude of the velocity here. So it's going fastest right here in this interval because we have the steepest slope. It's going, well, it's standing still over here, and it's going a little slower in this interval here, and it's going in a negative direction. Okay, so I hope that helped, and we'll come back and talk about acceleration next.